So here we have an improper integral, and this one is obvious to see why it's improper. It's unbounded on the top. We're going from 1 to infinity. So we can't really handle infinity as an upper limit. So to take care of this improper integral, we're going to fix that really quickly. We're just going to take the limit, as usually the upper limit would be called b, the general representation of that. Lower limit's usually called a. So we'll take the limit as b goes to infinity and kind of set up an equivalent integral here, but one that we can handle because now we have constants as our limits. So now you just integrate this as normal and then apply the limit. So this process is pretty simple. You've done all this before. So this integral, first of all, is going to require a U substitution. Now you can see that we have x squared up top, and we have this expression in this squared term, x cubed plus 2. So we know if we let u be x cubed plus 2, du is going to be 3x squared dx. So that's going to take care of this. And I'm going to do this on the side just so it doesn't get in the way. We're basically going to have the integral 1/3, because that x squared dx is du over 3, times the integral of 1 over u squared. And remember, that's u to the negative second, so you add 1, u to the negative first, and divide by a negative 1 or multiply by a negative 1. So that's the result of our integral. So I'm going to come back here and write the result. I have negative 1/3 times u to the negative first, and we're integrating that from 1 to b. So there's your answer, basically. The negative 1/3, can be factored out of the integral, and this process of evaluating the integral, it can also be factored out of a limit. We remember that from limits, and I usually just do that because it just gives me less to think about at this point right here. Let's see, this was x cubed plus 2. X cubed plus 2. That was our u. I meant to plug that in right away. And I caught that I factored out the negative, so here we go. So now we're going to use the fundamental theorem of calculus and plug in the upper limit. So we have 1 over b cubed plus 2. Plug in the lower limit. We have 1 over 1 plus 2. And now just apply the limit. So negative 1/3. This expression is a rational expression. The degree of the bottom is 3. The degree of the top is 0. So we know from our study of infinite limits, this would be 0. The other way to think about it is if you plug infinity in for b down here, it's a huge, huge, huge number. 1 divided by that huge number is going to be 0. The limit doesn't affect that constant. So the solution here is negative 1/3 times a negative 1/3, which is positive 1/9. Now you can check this on your calculator. The way I do it is I'll graph this. I'll zoom out a lot and I'll just integrate from 1 to however far I can get up here, and it should come close to 1/9. There you go.